Hello everyone. In the previous module, we discussed about the Ampere circuit law and its application. Today we are going to start with the part that is a solenoid and toroid. The firstly question is, what is a solenoid? A solenoid consists of a long wire which is bound with the form of a helix and turns are closely spaced. Its condition for the solenoid is the length of a solenoid. It should be very much as compared to its diameter. So for making the solenoid, the condition is it is in the form of a wire bound with in the form of a helix, and the length of a solenoid should be greater than as compared to its diameter. If we will see in a diagram, the current is flowing through it. If we will consider a single part, every part will behave like a circular coil. Circular coil means the current is flowing through it. Current is flowing means the magnetic field will be created around it. If the magnetic field from this part, the total magnetic field will be the vector sum of all the magnetic fields. Now, if we will consider a point which should be outside the solenoid, the magnetic field oppose this magnetic field and it will become weak. Means at a point outside the solenoid, the magnetic field due to the neighboring loop oppose and the effective magnetic field will become weak. When the solenoid is more and more tightly packed, the magnetic field due to the current through the solenoid will become zero. Now, we will consider a solenoid and we are considering a square loop, that is PQRS. Its a number of turn will be N and the I current is flowing through it. Now we are considering a ampere circular loop, that is PQRS. Its length is L. We are taking a small portion, that is a DL. The current flowing through it, that is a I. Now we have to find the magnetic field through overall this solenoid. So the magnetic field will be integration of B dot, according to Ampere circuit law, it's integration PQRS B dot DL in individually, that is P to Q, Q to R. We can see from the diagram P to Q, Q to R, R to S and S to P. Now, we can write it in the form of a P to Q B dot DL plus Q to R B dot DL plus R to S B dot DL plus S to P B dot DL. Here, P to Q B dot DL. P to Q dot product is there, the cos theta. The angle, the means magnetic field and the length both are in the same direction. The angle between them will be 0 degree, cos 0. B P to Q DL BL. That is BL. If we will take Q to R, second diagram, Q to R and S to P. This is DL, this is magnetic field. They both are in a opposite perpendicular direction, means the angle between them will be 90 degree, means cos 90 0. Now here the magnetic field from this part, that is a S to P and R to S, that both will become 0. Now P to Q R S, that is a BL. We already find it as from Ampere circuit law, PQRS B dot DL, that is a mu naught into total current through the circuit. That is mu naught into number of turns into current, mu naught NLI number of turns, that represented for the number of turns into the total length. Number of current, capital N, that is a total number density. Number density means NL, that is a N into L. N represent number of turns, L represent for the total N. Equating 2 and 3, we will get BL is equal to mu naught NLI, B is equal to L will be cancelled out, mu naught NI. At a point near to the end of solenoid, the magnetic field is found to be mu naught NI by 2. This is according to the Ampere circuit law, B is equal to mu naught NI. Now come to the part toroid. The toroid is a hollow circular ring on which large number of insulated turns are of metallic wire or closely bound. It is a endless part solenoid. We will consider n number of turns here according to the Ampere circuit law, that is B dot DL is equal to mu naught I. Since this loop does not enclose any current, so we can write B dot DL is equal to 0, means magnetic field is equal to 0. The line integral of magnetic field around the closed loop. Closed loop means B dot DL, means outside we can say that the no current is flowing, B is equal to 0. outside that was for the inside. Outside B dot dl is equal to mu naught I. The net current enclosed by this loop I is equal to 0, P is equal to 0. Line integral of magnetic field, that is B dot dl is equal to mu naught I, total current into the mu naught times. B dot dl means B dl cos 0 degree mu naught Ni. Ni is a N into L, that is a length, that is a 2 pi r into I. 2 pi r will be cancel out, we will get B is equal to mu naught Ni. Means the result for the magnetic field for the toroid and the result for the magnetic field for the solenoid, the both will be same but the derivations are different. We have to do all the derivations because any derivation can come in a CBSE paper. In the next module, we will start with the second part of a magnetic field. Thank you.